Hello everyone, welcome to today's session, Zero Carbon Emissions in Digitalization, the first episode of the Digital Climate Emergency webinar series, hosted by the Copenhagen Center on Energy Efficiency and Danish Data Center Industry. My name is Wang Xiao, I'll be your moderator. I lead on the sustainable data center work here at the Copenhagen Center, and I'm excited to be hosting this session today. First, I would like to inform all of you that we comply with the General Data Protection Act, also known as GDPR. This means that your personal data, such as name, email, workplace, is safely processed and stored, and all of your rights pursuant to the GDPR are respected. You have full access to the data being processed about you, and at any time, you can request that inaccurate data be deleted or rectified. For access or further information, please contact with the people that are presented here. A few things about the Copenhagen Center. The center conducts research and advisory activities in the field of energy efficiency and serves as energy efficiency hub for the Sustainable Energy for All initiative. The center has an established network of global, regional, and national partners with a broad range of stakeholders to help accelerate the implementation of energy efficiency activities. One of Copenhagen Center's focus areas is on smart energy and sustainable data centers, and it is supported by UN Environment Programme's United for Efficiency initiative. We aim to accelerate the global uptake of energy-efficient technology and solutions and facilitate multi-stakeholder collaboration on energy efficiency opportunities, with the vision that sustainable data centers and ICT technologies for lighting, appliances, and equipment become a key contributor to the UN Sustainable Development Goals on climate and energy. For this project, we have adopted an integrated policy approach. The priorities and perspectives of key stakeholders are addressed in each of these areas as shown on the graph. As you can see, apart from the standards and regulation, policy, finance, and sustainability benefits, we have added a special focus on cybersecurity and data protection in support of the generation of trust and security across the entire value chain of the digital economy. If you are interested in knowing more about this project, you can find the link to the project webpage on this slide. If you have extra curiosities on the global growth and energy efficiency potentials of the data center industry, we would like to provide you free access to our past webinars on these topics. As the webinar series is a joint effort between the Copenhagen Center and Danish Data Center Industry, I would like to invite Mr. Henrik Hansen, CEO of DDI, to quickly introduce themselves.
My name is Henrik Hansen and I'm the director of DDI, the Danish Data Center Industry. DDI is working to attract data centers to Denmark, as well as developing the ecosystem surrounding the industry in our country. We represent more than 75 member companies and organizations in and outside Denmark. Our primary activities are events, networking sessions, market reports, international cooperation, and building of partnerships to develop new technical and sustainable solutions for the industry.
Thanks, Henrik. Just a little housekeeping before we get started. If you have any questions during the presentation, please type them into the question box through the message icon. Please do not forget to mention the name of the panelist that the question is for. We will have a dedicated Q&A session, and I will bring them up there. Now, without further ado, we will turn the time over to Anna Cardoso, researcher of UNEP DTU Partnership. Anna is specialized in software development and has a PhD in technologies and information systems. Please, Anna.
Welcome to this presentation about greenhouse gas emissions in the ICT sector. I'll be talking about trends and methodologies for assessing the greenhouse gas emissions in this sector. But first, let's see what is the ICT sector? What is included in this sector? The ICT sector is the sector of information and communication technologies. It includes computing devices such as laptops and personal computers for personal use, and also mobile devices. Includes tablets and smartphones, these mobile devices, and also data centers and all the equipment they contain. The communication networks that allow data to be communicated between different computing devices are also included here. Some authors include also the equipment for entertainment and media, such as printers and televisions, which also use communication networks for sending and receiving data. More commonly, the studies we see in the literature, they consider the ICT sector to include computing devices, data centers, and communication networks. There are few studies that also include equipment for entertainment and media. Why do we need to be concerned about the ICT sector? We need to be concerned about the ICT sector because the ICT sector is an energy-intensive sector, and energy is causing greenhouse gas emissions. We have reached a significant milestone with the Paris Agreement, in which the world countries agreed to reduce their emissions in order to stabilize the world climate system. And to avoid dangerous climate change, there is a need for all countries to contribute to reduce their emissions. So they pledged, when they ratified the Paris Agreement, they pledged to do some reductions in their greenhouse gas emissions. But as we can see in this graph here, currently, with the measures that the countries committed to do with the Paris Agreement, the so-called NDCs, which stands for Nationally Determined Contributions, there is still a gap of emissions that needs to be met by additional reductions. So this is what is expected to be achieved with the conditional NDC scenario, which is the scenario in which the developing countries will receive support for doing additional reductions, and the unconditional NDC scenario, which is the scenario that that all countries will do irrespective of support being provided. But what is needed to stabilize the climate and the climate system in a range of safe global warming worldwide, the 2 degrees range, there is still this gap here between this orange line and this blue line. And if we want to achieve the 1.5 range of average increase in global temperature, the gap is still wider. So there is a lot to be done for reducing emissions, and all sectors needs to step up and contribute. The ICT sector is a sector that contributes in terms of emissions, but also can have a role to play as part of a solution to reduce emissions. In this figure here, we see that ICT has direct effects, which are direct environmental effects of production, use, and disposal of ICT. And these effects can be assessed with a life cycle approach. This is where the bulk of carbon emissions happen. It's related with the life cycle of ICT, the production, the use, and the disposal of ICT equipment. The level 2 here refers to enabling effects. These are the effects of applying ICT solutions to other sectors. And here we can have both positive and also negative effects. On the negative side, we have induction effects. This is when we applied ICT, and this stimulates consumption of other resources. So it puts pressure on consumption of other resources. For example, when we have ICTs like printers, it puts stress on a resource like paper. And we also have obsolescence effects. This happens because when the useful life cycle of ICT resources is reduced due to programmed obsolescences. And this happens, for example, when software updates are not compatible with equipment that is certain years old, and so it means that that equipment can possibly still work, but because there isn't software compatibility, it will have to be substituted, and that's a way of reducing the useful life of equipment, and thus causing more emissions to be happen. On the positive side, on ICT as part of the solution, we have substitution effects. When we apply ICT and this replaces other resource. This happens, for example, with ebook readers, because we now have these devices that allow a single device to have multiple books. We're printing less books, or we can reduce the number of printed books. Optimization effects. This refers when we apply ICT and this reduces the use of other resource. Like, for example, when we improve our lighting and we have so-called smart lighting solutions, it reduces the total consumption of energy, because the lighting allows that the energy consumption is reduced, because it adapts to when the room is being used and when the room is not being used. And we have level 3, systemic effects, where ICT is also part of the problem and part of the solution. In this case, we see ICT, we are looking for ICT to cause long-term behavioral change and economic structural change. On the negative side, we have rebound effects. When this happens when increased efficiency caused by ICT is not achieved because resource is used more frequently or more intensively. So it can be when we apply ICT, for example, and to become more energy efficient, but instead of reducing the total energy consumption, it ends up becoming more or less the same, or could even increase a bit, because the resource that has been turned more efficient is now used more often or more hours. And emerging risks. This happens when we have new risks. It can be different things, like, for example, security, due to vulnerability of ICT. On the positive side, ICT has the potential to support more efficient processes for sustainable patterns of consumption and production. So all in all, ICT has this set of negative effects, some direct and some indirect, and also positive effects. So it is complex to determine what is actually the contribution of the ICT sector in terms of emissions and all the other environmental impacts. In this slide, I'm showing the global greenhouse gas emissions in the ICT sector, as it has been reported in different studies by a group of authors. Here on the left is the share of global greenhouse gas emissions in 2007, and it ranges from roughly 1.3 to 3% in the study of Malmodin, which was published in 2010. Another study that is more recently, in 2018, found that the ICT share is possibly less than previously thought, and it's a bit like 1.1% to 1.6%. As can be seen, there is a bit of uncertainty in terms of what is actually the ICT share of global emissions. So if we look into 2020 and even into 2030 and 2040, there is this trend of ICT sector global share on emissions to increase. So this study from the same study from 2018 found that the share of global greenhouse gas emissions of the ICT sector will be a bit over 3%. which is twice the value of 2007. Another author found that this could be between 3% and 6.2%. And if we look here, the same group of authors, Belkier and Andre and Eller, they have also estimates for 2030 and 2040. And here there is a lot more uncertainty, but what we see is that the share of greenhouse gas emissions of the ICT sector globally will increase substantially, because Andre, for example, predicts that it will be between 6% and 23% in 2030, which is a significant percentage of global emissions. Belkier and Elemeligi predicts that it will be a bit above 5%, 5.2, up to 14% in 2040. So it cannot, as we can see between these two estimates, there is large uncertainty on what will be the share of this sector in global emissions. It can be as little as 5.2% or as much as 23%. But the expectation is that it will grow. So it seems like the ICT sector's energy footprint is increasing, but not as often assumed. It is assumed that it increases in line with data volumes, but it's also increasing in correlation with the increased volume of subscriptions of data. So there are some problems with these studies. One of the problems is the assumptions. The assumptions that these authors made in these studies are not always comparable. The sector definitions and the geographical and temporal system boundary are not always the same, and then they cannot be compared. Also, another problem is that some of them assume that the Moore's law will continue, and it is not correct to assume that that will be the case. We still don't know. And also the assumption that historic law can predict future when we don't exactly know how and which devices will be produced and will be used in the future. For example, in 2007 and before, it was not yet foreseen that we would have as many smartphones as we have today. So as of today, we don't know what ICT devices will be in the market in 10 and in 20 years. So it is quite difficult to do this estimates of emissions of this ICT sector. If we look at the relative contribution of ICT categories, and that is what is included in the ICT sector, from the study that is more recent of Belkier and El-Meligi, we see that data centers in 2010 had a percentage of 33% in their relative contribution, but in 2020 this is expected to be 45%. So it is actually increasing in terms of the data centers' share of emissions. The others are relatively the same, except that smartphones has increased, but desktops has decreased a bit. So there is a bit of a substitution effect on this part. We can also look at what has been published in the research literature about greenhouse gas emission reduction potentials by ICT solutions. And there is this study from one of the authors is the same that published some studies before about the share of ICT sector in global emissions. It's Malmodin. And in 2030, it seems that there is this potential of global greenhouse gas reduction in 2030. It varies between 7 to 30%, 13%. These authors, they estimate the reduction potentials for different ICT solutions in sectors like smart grid, integration of renewable energy, balancing of power load, smart metering, and power grid optimization. And here, the reduction that can be caused by applying smart grid solutions ranges from 1.6 to 3.9%. Also, in smart buildings, with automated heating, ventilation, and air conditioning systems and light control, smart transport, smart travel, smart work, and smart services. Overall, the range of global reduction potential by applying ICT solutions goes from a maximum of when we add all the lower bound of the range, maximum of 7%, and a minimum of 7% and the maximum of 13%. So there is potential for ICT contribute also to reduce a significant amount of greenhouse gas emissions. This has, of course, to be compared with the emissions caused by the sector, because this study here does not factor the footprint of the ICT solution itself, only factors the impact it causes indirectly, not the direct impact that it has from production, use, and disposal in its life cycle. In China, the same has also been verified. The internet data usage has increased substantially from 2012 to 2018. In terms of data centers' increased efficiency, we also see that the ICT industry has become a big purchaser of renewable electricity. So from 2010 to 2016, the number of agreements to purchase renewable electricity in this sector increased significantly. And it roughly averages half of the corporate agreements. In terms of connected Internet of Things devices, there's also a big increase in number of devices, from 5 billion IoT devices in 2016 to an expected more than 20 billion IoT devices. And this has increased, and this will increase mostly in the consumer segment, which is the largest user of connected things. This is, for example, smart TVs, automotive systems. In the business segment, it's mostly smart meters and security cameras. Greater China, North America, and Western Europe are driving the use of these connected things, and the three regions together, they represent 70% of overall Internet of Things installed base in 2018. In terms of applications of ICT sector in Internet of Things, we see here that with this Gartner's priority matrix, it offers a snapshot of the relative market promotion and perceived value of innovations in this area. They estimate that Internet of Things will reach mainstream adoption. A lot of what we see related applications of Internet of Things will reach mainstream adoption in 2 to 5 years, significant number of things in 5 to 10 years. This means there will be a lot of growth in this area. And now we look at smart cities. In terms of mainstream adoption of the technologies for smart cities, there's also this expectation that it will reach it will be mainstreamed. Not so much some in 2 to 5 years, but a lot in 5 to 10 years and a little bit more than 10 years. So, considering that the majority of population will live in cities, smart cities are a hot topic. Smart cities and intelligent urban ecosystems are using an integrated approach to digital technology to collaborate and engage with citizens, businesses, and governments, local governments. In 10 years' time, it is estimated mainstream adoption of many energy-intensive ICTs, like 5G, smart buildings, vehicle-to-vehicle communications, blockchain business models, and chatbots. This will put a lot of pressure also in energy use, as all these devices will need energy to be powered and to operate. Now we look at methodologies that exist for carbon footprint in the ICT sector. We have here on the left in the green, in the darker green color, a set of guidelines for assessing the environmental impacts of ICT goods. Some have been developed by the Greenhouse Gas Protocol for ICT sectors, others were developed by the Green Grid, and some other developed by the International Commission on International Electronic Commissions. This here. There are also some guidelines for assessing the environmental impact of ICT services here. Some were developed by the European Telecommunication Standards Institute, and they also apply to goods. So they apply both to goods and services. And others were developed by the Greenhouse Gas Protocol, and they apply to services only. And for assessing the environmental impacts of ICT at organization or project level, we have the guidelines developed by ITU, the International Telecommunications Union. This organization, the International Telecommunications Union, also developed a methodology for environmental impact assessment of ICT at city level. These methodologies exist and are well explained in this source, ictfootprint.eu. They can be applied, as I said, to goods, services, organizations, projects, and cities. And they use a life cycle analysis approach. Now looking at tools that already exist for measuring carbon impacts. In this table, there are a list here, tools that exist that are commercial or free. We don't endorse any. Just it's a compilation of what is available and what was found by desk research. And we have tools for measuring the carbon footprint of websites. We have this one for a self-assessment of the climate change and primary energy footprint of an organization, and others that measure footprinting at the footprinting at the product, company, and value chain level, and some more specific for measuring the footprint of mobile apps and also the environmental impact of software based on how efficiently it carries the intended actions and how robust it is. Now, talking in terms of the key takeaways from this talk. Well, we can see that the trends in the ICT sector, the trends of growing applications, number of applications of ICT sector, like for example, Internet of Things, smart cities, and the number of internet users and mobile users and the hours they spend on using their devices, potentially turn this sector in the coming years into a significant contributor to global greenhouse gas emissions. So with this, I would like to call for more awareness and about this potential future issue and the need for optimizing this sector for energy efficiency. And here I would like to talk a bit about the United Nations Environment's United for Efficiency program. It's a global effort supporting developing countries and emerging economies to move their markets to energy efficient appliances and equipment. And it's helping these countries to leapfrog and adopt the more efficient solutions that they need in different areas, including in the ICT sector. Also, because we've seen that the estimates we have of the share of emissions of the ICT sector have a lot of uncertainty, we need to have more estimates of the impacts of ICT devices and ICT solutions, published with open, transparent data so that we can improve the quality of these estimates and reduce the uncertainty. And finally, I would like to call for prioritizing sustainable human-computer interaction. This focuses on the relationship between humans and technology in the context of sustainability. So here, two possible ways. So sustainability through design, basically, how can we design technology and ICT systems to support more environmentally sustainable lifestyles and promote environmentally sustainable behavior? And also, another part will be sustainability in design, concerning with how can technology be designed such that its use is made sustainable, environmentally sustainable for its entire lifetime of use. So designing sustainably and using technology solutions to encourage environmentally sustainability and environmentally sustainable behaviors. And with this, I would like to thank you for listening to this presentation, and thank you for being a great audience.
Thank you very much, Anna. Next, we have invited the CEO of NodePol, Patrik Öhlund, to share his perspectives and insights on the business opportunities and market-driven labeling schemes for decarbonizing the data center industry. The floor is yours, Patrik.
Thank you for joining this webinar. My name is Patrik Öhlund. I'm heading up a company called NodePol, we are providing energy-focused site selection services in the Nordics, and I'm also the chairman of iMason's Sustainability Committee. Today, I'm going to talk to you about how the market demands are changing and developing rapidly, and also why this is relevant to the data center industry, and also we're going to talk about how this can be turned into an opportunity for your business. I'm sure that many of you have heard about Fridays for Future. We see young people all over the world that are mobilizing to put pressure on politicians and company leaders. Now, very recently also with the UN Climate Summit in Madrid. We believe this is a reflection of a growing concern about the climate all over the world. And this is starting to cause a change to how customers think of their service providers, both at work and at home. With this rising change in market demands, it will be impossible for companies to ignore their climate impact. The power of influence by the global movement can be exemplified by 16-year-old Greta Thunberg from Sweden. In a very short time, she has become a global symbol for the concerns of our children. She is now known and followed by millions of people around the world, and recently she ended up on the cover for Time magazine, and even more recently she was appointed or named the Person of the Year. All this in a very, very short time. To look into people's attitudes and expectations, what we did at NodePol was that we conducted a survey earlier this year covering 3 continents, the US, Europe, and Asia. We asked over 4,000 people about their opinions, and we found some really interesting results that I would like to share with you. What we saw in this survey is that a majority of the people that we asked, they are worried about climate change, and they are also convinced that this situation is man-made. The survey also indicated that more and more people are making the connection between internet services and their climate impact. As an example, 86% could consider to select their service provider based on climate impact. Furthermore, the message was quite clear. People have expectations on businesses to take responsibility and to lead the way. So to conclude and summarize, we see a growing number of people that are seriously concerned and expect businesses to make a shift for a more sustainable setup. So why is this relevant then to the data center industry, and how can this be turned into a business opportunity? As most of you know, our industry is growing rapidly and needs an increasing amount of energy to function. There are many numbers floating around about the amounts of energy that is needed to power up the ICT industry. But I think we can agree that the numbers are significant enough, and they are growing rapidly as a consequence of customer demands. This happens while the global energy production is still relying heavily on fossil-based energy sources and will continue to do so. So what does this mean for our data center industry? We believe that companies need to go sustainable to maintain market shares. So what does it mean then to go sustainable? This means that you need to drive the build out of renewable energy production. You have to run your operations as energy efficient as possible. You also have to minimize carbon emissions from energy consumption by using a location strategy that promotes electricity grids with low carbon emissions and or add more renewable resources. A lot of action is already happening around the industry, which is of course a great thing. We see that the hyperscalers have since long embarked on a road for a more sustainable future and are setting examples for others to follow. Some of you might be aware of that these companies have made clear commitments a long time ago and have already come a long way. As part of my work in iMasons, we recently handed out the Sustainability Champion Award to Yokawa at Google to acknowledge their great achievements, in particular when it comes to buying and procuring renewable power. I will not go into all the details now in this presentation, but I do encourage you all to find out more about all the good stuff these companies are doing by paying a visit to their corporate sustainability websites. Question then is, how can you follow the big guys and turn the changed market demands into an opportunity for your business? At Notepole, we strongly believe that this can be achieved, and I would like to share some thoughts with you on how this can be done. We have seen that customers, and this includes both consumers and businesses, would like to take action and make conscious choices, and also want to tell others about their choices. We believe that this should be clear to most management teams today. This means that data center operators and service providers need to take action if you aren't already doing this. However, we believe that doing this is not enough. You also need to tell your customers about this. So you should ask yourselves, are you greenwashing or perhaps even greenhushing today? On the screen here is a very simple model to understand the impact from the combination of what you're actually doing in terms of sustainable operations and how you are communicating about it. In the upper left corner, you have greenwashing, meaning that you are talking a lot about sustainability, but you might not do the real thing. In the lower left, you are not doing much and you're not talking about it either, meaning that you're indifferent to market change. Here you will find yourself at risk of losing market share, but also you will see and face lower trust by your customers. Some of you might take some really strong action already, but you're not perhaps telling the world about it and telling your customers. This means that you're what we call greenhushing, and you're not really reaping the full benefit of what you're doing. If you're both taking some real action on sustainability and you have found a good way of telling the world about it, you have really positioned yourself to capture market share, and you are bound to face in increasing trust from your customer base. This means that you have turned the sustainability challenge into a business opportunity. If you're already finding yourself in the upper right corner, that is really great, and I would like to congratulate you. If you're in one of the other three boxes, however, you need to ask yourselves if you need to take some sort of action. If you're in the two left boxes, you have to start to take some real action, and you need to go sustainable. If you're already doing this, but you're not very good at telling the world about it and telling your customers and other stakeholders, and if you aim then for the upper right corner, we have developed something that we believe that you might find useful. And this is the new label scheme for fossil-free data that I will tell you a bit more about. What we at Nodepol have done is that we have created a new global label scheme for fossil-free handling of data, and we call it fossil-free data, simply. Fossil-free data is energy efficient. It reflects this is reflected in a PUE that is below 1.4. It is also very low in carbon emissions, below 0.19 kilograms CO2 per kilowatt hour IT load. And of course, you're also buying renewable energy to your data center operations. These criteria are based on the data center performance index developed by the infrastructure masons. If these criteria are fulfilled, you can get certified through a simple process, and you can use this to tell the world about how you take responsibility for a sustainable future. How does this new label then fit into the bigger picture, and to what extent is this aligned to the sustainability development goals set out by the United Nations? Our label is directly related to SDG number 7 on affordable and clean energy, as the label promotes the use and build out of renewable energy. It also increases awareness around data centers and energy usage. By meeting the label criteria, companies are contributing directly towards SDG number 7. So to learn more about the definitions and how to apply on this new label scheme, you can go to fossilfreedata.com. And I hope to get in touch to discuss this further with you. Thank you.
Thank you for your presentation, Patrik. Dear participants, we will now start the Q&A sessions. In case your questions are not selected, we will be forwarding them to the recording speakers. So the first question is to Patrik. The participant would like to know, is cloud computing a green solution to reduce data center carbon emissions? I know we did not touch upon the topic on cloud in this episode, but we will be having one episode dedicated to energy efficient cloud solutions. So for those of you who are interested in this topic, please stay tuned. And for now, Patrik, could you briefly provide your opinions on if and why cloud could be a way for data center decarbonization?
Regarding cloud computing and whether this is a green solution to reduce data center carbon emissions, the short answer is yes. According to the International Energy Agency, the strong growth in demand for data center services continue to be offset by continued improvements in efficiency, much thanks to the increasing market share of cloud and hyperscale data centers. Hyperscale data centers are very efficient compared to traditional on-premises data centers. Some studies claim that the cloud solutions can be as much as 93% more energy efficient. When you combine this with the fact that cloud giants like Google and Microsoft are being very proactive in running their operations on renewable power, it is easy to see that cloud computing is a smart way to reduce carbon emissions.
Here we have another question, also to Patrik. The world is increasingly becoming digital and connected everywhere. How do data center providers achieve the balance for load growth and corporate sustainability pledge to support UN Sustainable Development Goals? I think it is a very good question, Patrik. What do you have to say?
My take on this is that the data center providers that are leading the development in sustainable development are looking at the problem from a holistic perspective. They are addressing everything from energy efficiency, procurement of renewable energy on a 24/7 basis, removal of diesel generators, reuse of waste heat, minimum or no use of water for cooling, zero waste philosophy for material, etc. They look at their entire operations end to end and apply a sustainable approach in all aspects. This way, they support several of the sustainable development goals at the same time.
Speaking about holistic views from the industry, we have a question to Anna. Do you have any numbers to show the breakdown on carbon footprints by ICT consumer sectors? What can we learn from the data?
From the research that I've reviewed, I have not seen this detail except for that graph that I showed, where you can see by ICT categories the data centers, the computing devices, mobile devices, and networking equipment. What we can learn from this data is that if we want to have more detailed data in this breakdown, it would be necessary to collect data with that level of detail. So at the moment, as I said, there is a need for better and more data about these different categories of ICT. What we can learn from what we have today is that there is a significant level of uncertainty about the carbon footprints in all these sectors. The estimates that have been done for the future years range from values that can be as low as 7% or as much as 23%. And we also don't know how technology will evolve. So we don't know what devices will be in the market in 10 years from now and in 20 years from now. So it's a sector that, because it's highly innovative, it will be difficult to make these estimates with with reduced uncertainty and better, more aligned to what are the expectations for the future of this sector.
I've got another question which focuses on individual consumers, and it is to Anna. How and how much do we contribute to ICT-related carbon footprints as an individual consumer?
I think this question is very relevant, but it's very difficult to answer because at the moment we have it's very difficult to calculate this individual carbon footprint, specifically for the use of ICT equipment that we have. But I think it's an interesting and an opportunity for doing research on this area to develop the tools to assess this footprint, the carbon footprint of individual consumption of ICT equipment and services. So I think it's a very relevant question with which needs to be researched, and I think clearly there's a need for tools to provide this information to individual consumers so that they can be more aware of what is their carbon footprint and also what they can do to reduce it.
Okay, everyone, as we are approaching the end of the session, if anything else you wanted to cover, please get in touch. If you find this topic interesting, we warmly invite you to join us at the Data Centers Denmark 2020, which will be held on 13th of May in the UN City in Copenhagen, Denmark. We will be discussing the latest energy-efficient innovations and approaches from the industry to build and operate climate-positive data centers. Dear participants, if you find our webinar helpful, we will be much appreciated. Thank you for being here with us today. We are looking forward to seeing you at the conference in Copenhagen. and to you next time.